question that I gave you for homework last time, and it was just an opportunity to practice what it was that we had been doing. This one was a little bit more difficult, but not a lot more difficult if you're okay with your grade 11 Euclidean geometry. All right, so in the first instance, in 4A, we had to prove the triangle PAB was similar to triangle ABC. So we had parallel lines, so we could use alternate angles for A1 and B2. Then we could get B1 and C through tan chord theorem. So that was something that we haven't seen before. Okay, so that was the sort of trick to nail with this one, is angle B1 was equal to angle C. So the angle between the tangent and the chord is equal to the angle in the alternate segment. Okay, that's what tan chord theorem is. And then, of course, P equals A2 because of the angles of a triangle, concluding that they are similar, writing AAA, then putting the corresponding sides into proportion. So please take screenshots of all of this. Those are the ones that I've highlighted in purple were the ones that they wanted. And then the last one, again, they came from the first proportion, and then they wanted us to switch things around. So in other words, AB was down here at the bottom and BP was at the top. And you can now see here, AB is at the top and BP is at the bottom, and we're allowed to do that. Okay, so remember, if I have 1/2 is 5/10, I can interchange 5 and 2 or 1 and 10. All right, so I can write 1/5 is the same as 2/10. That's why I'm allowed to do that. Okay, so those were the answers. Hopefully everybody is good with all of that. We're now ready to go on to the next lesson, which is all about similarity again, but this is now stepping up. Whilst we're still on the screen, before we go on to the next screen, I want to point something out to you. The reason that we talk about this being the basics is because here they have told us which triangles to work in. And then questions B and C follow on from us being able to prove similarity. Now, contrast that with this. Okay, let's have a look at this example. They've given us two circles. They've told us that they intersected A and B. They tell us AC is a tangent to the circle. So the minute we see the word tangent, we need to start thinking about all the theorems that are associated with tangents, like tan chord theorem or radius perpendicular to tangent. That might be useful in proving angles are equal to 90, etc., etc. The other thing that they have told us is that AD is a tangent to circle ABC. Now, I see there was a hand up. Hang on a second. Ntabileng, do you want to ask something quickly?
I'm not sure if Ntabileng is on audio. I think Ntabileng cannot connect to audio yet.
Oh, okay.
You can see my messages on the chat.
Okay, all right. Hopefully she's reading that. Okay, so let's just go back to what they're telling us about tangents here, and then we'll talk a little bit more about the first question. When they tell us that AC is a tangent to circle ABD, let's just go and find tangent AC. Here it is. Okay, now if a line is a tangent to a circle, it means it touches the circle in one place only. Now, I know there's a lot of lines going on here. Okay, now look at circle ABD. It's the smaller circle on the right-hand side. All right, which is the angle that is between the tangent and the chord? The chord is AB. So the chord is AB. This is the chord over here. What's the angle called that is between the tangent and the chord? What's it called? You can pop it into the chat. The angle between the tangent and the chord is angle.
Let's go, guys. Open your notes. Open your notes. We have this. We have it.
The angle between the tangent and the chord is which angle? What angle are they referring, or am I referring to here? Does any, there we go, beautiful. All right, angle A1. There we go. That is the angle between the tangent and the chord. The chord is AB, the tangent is AC. Which angle is it equal to, Matrix? The angle in the alternate segment. What angle is it equal to? Let's see what you guys say. It's equal to angle. Yep, A1 is right. Yes, Asanele, yes. Okay, Ayanda, The angle between the tangent and the chord, angle A1, is equal to the angle in the alternate segment. So that would be angle D. Okay, good. Yes, Miss Ba, that's quite right. Okay, that is how they want you to interpret this information. Okay, so AC is a tangent to the circle ABD. They're trying to tell us that A1 equals angle.
Sorry, Teacher Lee, I have to mute everyone because I couldn't find who was talking. Sorry, you can unmute.
There we
Jenny,
go.
there we go.
There we go. Sorry. It just took me a little while. No, don't apologize, Yolanda. It just took me a little while to find myself. Okay, now they also tell us that AD is a tangent to the circle ABC. So now that I showed you with the blue one what to do, I want you guys to tell me which angle are they trying to insinuate, which two angles are they trying to insinuate are equal to one another here. So telling us that AC is a tangent to circle ABD, they are trying to tell us that A1 equals D because of tan chord theorem. So as far as the yellow is concerned, telling us that AD is a tangent to circle ABC, which two angles are they implying are equal, matrix? Which two angles are they implying are equal?
We can do this, my people. We can do it. Remember that you can just shout out an answer.
Absolutely. So Lorato says A2 and C, so do Menentle and Sean. Oh, you guys are brilliant. Brilliant. Fantastic. Well done. Okay, so they are implying by that A2 and C are also equal to one another. Okay, so we can jot these little bits of information down because no doubt we're going to use them. Can you guys see the yellow, by the way? Yolanda, is that visible?
Yes, it's perfectly fine. It's
okay, all right. I was always worried about yellow because I'm not sure it's a brilliant color to use or not. Okay, now let's have a look. Now that we've established that, let's have a look at the first question. The first question says we need to prove a proportion. So BC over AC equals AB over AD. What's different here to what we saw last lesson? What's different now, matrix, to what we saw last lesson? What are we seeing now that we weren't seeing last lesson? Something's missing. Anybody got any idea with what's missing? So this question is a bit more difficult. No parallel lines in Konaiza, but yes, I suppose I can understand why you'd say that because the previous question did have parallel lines.
Yeah, and good try. Good try.
There we go. Trish. Woo. Look at what Trish said. We don't know what triangles we are working with. Well Bang done, on. Well done, Trish. That is exactly it. They did not tell us which triangles to work in. Okay, so here they've asked us a proportion, but they haven't told us which triangles we need to prove are similar first. That's why this sort of question is a little bit more difficult because we first have to figure out which two triangles are we working in. Now, when we do this, we are not allowed to write. Now, in maths, we're so used to writing, we see a question, we put the question on the page, and then we start to answer the question. But here, we are not allowed to do that. We are not allowed to begin by writing BC over AC equals AB over AD, because then we are making a statement like this is true, right? But we don't know that yet because we're still trying to prove it. So what I suggest you do is create just a little piece of paper or a little bit of thingy on the side and label this as your rough work that you can then cross out afterwards. Take your proportion and put it in there. So AB over AC is equal to AB over AD. Now, here are the tricks to how to figure things out, okay? The first thing that we do to try and find the triangles is we go across the top of the proportion. So in other words, what we are doing is we are looking at the numerators and we are saying to ourselves, is ABC a triangle? This is the big question. So now go and look at the diagram and ask yourselves, is ABC a triangle? Are there 3 straight lines connecting A to B to C and back to A again? What's the answer to that? Is ABC a triangle? Yes, beautiful. Okay, now we do the same thing with the denominators. Okay, AC, AD. So now we ask ourselves, is ACD a triangle? Is ACD a triangle? Go back and have a look. Is ACD a triangle? What's the answer to that? Correct. The answer is no. Okay, so ACD is not a triangle. ACD is not working. So when we went across like this, it didn't work. What we're going to do now, so if we first try across and it doesn't work, now we try around the outside. Okay, so now what we are looking at is this. Top and bottom and top and bottom. So again, we're asking ourselves, is ABC a triangle? We know the answer to that is yes when we go this way, ABC. All right, and the answer to that is yes, it's a triangle. What about ABD? Is ABD a triangle? ABD? Yes, there we go. All right, so that's how we find the triangles we need to work in. Okay, so either we go numerator and numerator and make a triangle, and denominator and denominator, does it make a triangle? If that doesn't work, you go around the outside. Okay, so ABC versus ABD, and that is our starting point. Okay, so we begin question A by writing, in triangle ABC and triangle ABD. Now, the problem is we do not know that that is the correct order of the letters. When we write in triangle ABC and ABD, it doesn't matter if the order is not correct. But when we make the statement at the bottom, therefore triangle ABC is similar to triangle whatever, then the order has to be correct. Because remember, we're going to use that order to write the corresponding sides in proportion. And if we mess the order up, we're never going to be able to prove anything that follows. Okay, I know I'm giving you a lot of information at this point. How are we feeling? Is this making sense so far? Happy, sad, thumbs up? Are we good, people?
There we go. Let's show some thumbs up while others are taking screenshots.
Thumbs down. How are you feeling? Is this making sense so far?
Okay,
okay, so some of us are happy, some of us are
still sad. Yeah.
Some of us are sad. Okay.
Screenshot, guys. Like this, we don't have to come back. Screenshots. Okay.
Okay. All right. So what is different here? Okay, I'm just going to go through this one more time before I proceed. Okay, my apologies, those of you that feel you understand this, but I think it's important that we just clear this up one more time. The difference in this question compared to the questions before is that they are not telling us which triangles to work in. So if we go back to our basics, here they told us, prove the triangle PAB is similar to triangle ABC. They told us which triangles to work in. So then when we did questions B and C, it was easy for us because we knew the triangles we were working in. Compare that to what we're doing now. Here, question A is not telling us which triangles we need to prove are similar. That's why this is more difficult, all right? But we are not allowed to write down BC over AC equals AB over AD. Our first statement on the page has to be the triangles that we are working in. So how we work out the triangles we are working in is by writing our proportion in rough and then comparing. We're doing two comparisons, numerator and numerator, and making a triangle. So the letters B, C, and AB, that makes triangle ABC if it is a triangle. And the letters at the bottom, A, C, and D. And we ask ourselves, is ACD a triangle? So now if you have a look at ACD, there's A, there's C, but there isn't a straight line connecting C to D. So it's not a triangle. Okay, there has to be a straight line connecting C to D for it to be a triangle, which there isn't. Because that didn't work, we now try the letters top and bottom. Okay, so now if we're looking top and bottom, we've got the letters ABC. We know that ABC is a triangle. On the right-hand side of the proportion, we've got the letters A, B, and D. So we ask ourselves, is that a triangle? And we can see that it is. So that is how we identify the triangles we are going to work in. Okay, so either numerators, denominators, they both have to work though, okay? If that doesn't work, we compare numerator and denominator, and we find our triangles that way. Now we're back to where we were before. We know what triangles to work in. Let's go and highlight them, and let's figure out and let's see if we can use what we already know, okay? So here is triangle ABC. And here is triangle ABD. Okay. Now remember, from our previous information, we already know something about angles here. So let's go and add that on. We know that angle A2 and angle C are equal to one another. Brilliant, because of tan chord theorem. We also know that angle A1 and angle D are equal to one another. Okay, so that is our similarity basically proved for us, because the remaining angles, which would be B1 and B2, they have to be equal because of the angles of a triangle. So by reading the information, establishing the angles that are equal, and then finding which triangles we're working in, we've actually already proved the problem. All we've got to do now is put it down on paper, okay? So first things first, we know that in triangle ABC, which is the blue one, angle A1 is equal to angle D. Our reason, tan chord theorem, as we said in the beginning. Second reason, we already know as well. So going back to the blue triangle, angle C equaled angle A2. Do you see how nice and easy it is if we use color? Okay, again, tan chord theorem was our reason. Now we're going to go back to the blue triangle. So we're starting with the blue triangle each time. There we've got angle B1, and it corresponds with angle B2 in triangle ABD. And this is the angles of a triangle add up to 180 degrees. Now, the reason why it's important to always work in one triangle is because of this. The order of the letters is so very, very important. Okay, so all of these angles over here belong to the blue triangle. All of these letters over here belong to the yellow triangle. And that's how we can get our order correct. So what I'm going to do is this. I'm now going to conclude. Therefore, triangle ACB, ACB is similar to triangle, okay, the order is important, DAB. Reason, angle, angle, angle. Okay, now again, I'm just asking, how are we feeling at this point? Is this making sense? Do you guys have any questions? Okay, so Lutanda, you said you don't understand how B1 is equal to B2. I'm not saying that B1 and B2 is a triangle. I'm saying ABC is a triangle and ABD is a triangle. If A1 equals D and angle A2 equals C, then angle B1, which is the third angle in the blue triangle, must be equal to the third angle, B2, in the other triangle. Okay, because of the angles of a triangle adding up to 180. Okay, so some positive feedback there. Are we sure we're okay? Are you ready for me to move on to the next bit? Makes sense. Okay. Katlejo, go for it. If you want to ask a question. Yeah, Rona, sorry, you've missed. Yeah, Zetu, very good question. What if it's not in order? Zetu, then basically the whole thing breaks down. Okay, because you will never ever be able to prove the proportions or the questions that follow. Okay, you will never ever be able to get something like this: AB squared equals BC times BD. Okay, so the order is very, very, very important. Not in the beginning in your initial statement, but over here. Okay, so I'm highlighting it in yellow. This bit over here, the order has to be absolutely 100% correct. Okay, but if you do what I have showed you, it's going to make life easy for you. So always go back. So what I do is the first thing that I write is always about the first triangle. And then the second thing that I write is always about the second triangle. And then I go back to the first triangle and then to the second triangle and then back to the same blue triangle and then back to the yellow triangle so that I can get my order. So ACB, DAB. All right.
Take screenshots.
There's two questions here. Katlejo, how do we see which is a numerator and which is our denominators? I'm going to show you that now. Okay, so we're going to write the corresponding sides in proportion now, Katlejo. Nkoniza, you're saying, sorry, let me just, sorry, Nkoniza. So the first half can be any order, but the second, yes. Okay, so in other words, Nkoniza, if I wanted to go ABC, so let's say I decided here to say triangle ABC. Then when I do it on this side, what was equal to A in the blue triangle, I have to start with that letter in the yellow triangle. So I have to start with D. If I'm talking about B, then here I would have to write B. And then angle C in the blue triangle goes with angle A. I could do that as well if I wanted to. Okay, so your angles have to match up. Angle A in the one triangle has to match up with the corresponding angle in the other triangle, the angle that is equal in size. Okay, so the order of the letters is very important. So now, irrespective of whether I write this line over here or that line over there, I'm going to get the same proportions because my order is correct. Okay, so let's go, is tan chord, yeah, when the angle touches, yeah. So in other words, there, sorry, I'm just answering a question here. Raphael, so tan chord theorem is, so AC is a tangent Angle A1 is the angle between the tangent and the chord. AB is the chord. And then AB makes D at the circle. Okay, so D is the angle in the alternate segment. Similarly, if AD is a tangent to the larger circle, angle A2 will be the angle between the tangent and the chord. The chord is still AB, and that subtends C in the larger circle. Okay, so that's tan chord theorem for you. All right, so now the next part, in order to answer the next question, which is AB squared equals BC times BD, we would never be able to do that if we did not have our order correct. Okay, so let's have a look here. First and last over first and last. So for B, we're going to do this. So AC, first and last, over first and last, DA, is equal to second to CB over second to AB, is equal to first and last, AB over first and last, DB. Reason, corresponding sides in proportion. Okay, you would not be able to make, because all your letters would be jumbled if the order wasn't correct. Okay, so we wouldn't be able to do step B correctly if we didn't have the order correct. Now let's go back and have a look what they wanted. They wanted AB squared. Well, AB squared means AB times AB, doesn't it? So it's got to be this AB over here and that AB over there is equal to BC. Here's BC. BC multiplied by BD or DB. That's this one over here. Okay, so now what they're asking us to do is take those last two fractions and, excuse me, cross multiply them. So in other words, we've got CB over AB that is equal to AB over DB, and now I'm going to cross multiply. That's how I end up with AB squared, AB times AB, all right, is equal to CB multiplied by DB. And then I've gone and answered the question. Okay, so take a screenshot of that. Yes, Katlego, you got your hand up.
Hi, ma'am. Ma'am,
Hi.
I kind of lost connection and I don't know what I missed. I think so far I understand what you did, but what I still don't get for number A is how is that proving that how is that proving the question? Because I forgot what they said. But how is that proving the question, ma'am, when you prove that
sorry. Yes, I jumped straight into, thank you. Sorry, Katlego. I beg your pardon. You're quite right. Okay, I went straight to the second part and I didn't even worry about the first one. Okay, so we would have to do, we would have to do the same thing. So this is the problem when you have to go up and down, up and down, up and down, up and down. Let me just go back here. Okay, so all of this is correct. What did they want us to prove? They wanted us to prove that BC over AC. So let's just rub this out and let's just write it again. Okay, so we've got first and last over first and last equals second to over second to equals first and last. First two over first two, second two over second two, first and last over first and last. Okay, so let's just, we've rewritten that. Now they want BC and AC. So where is BC? Here's BC. Where's AC? AC is over there. What else did they want? AB and AD. So there's AB and AD. Okay, so we would not be able to do this if we had got the order incorrect. So now that I have established that AC over DA equals CB over AB, I can now do whatever manipulation it is that they wanted me to make. So they wanted BC over AC. All right. So what they are doing here is they're putting one numerator over the other numerator. So BC over AC. So I'm putting this numerator over here over that numerator over there. This is going to be equal to this numerator, sorry, this denominator, AB, over that denominator over there, over AD. All right, and now we've proved it. Okay, Katlego? Sorry, I jumped straight into the second part of the question instead of finishing the first one off. Okay.
Sorry, ma'am, for just unmuting. I wanted
No,
to
go
know,
for
ma'am.
it.
Okay, ma'am. It's because Katleho has his or her hand up too. But ma'am, I wanted to know, ma'am, is this like the reasoning corresponding sides in prop, or is there?
No, that's it. That's the reason. Okay, so when you write the corresponding sides in proportion, that is the reason for it. Okay.
Okay, ma'am.
All right, no problem. Katlego, you're welcome to ask your question as well. Hi, Katlego.
Hi, ma'am. I was lost on how you come to find the first and last, second of last denominator and numerator.
Okay, all right. So in other words, so first and last comes from this line over here. Okay, so it's these two, this side over here, AC, over this side over here, DA. That's what this is. Okay.
Okay.
All right. Then side CB. So second and third, second and third. That's what this is over here. Second and third and second and third. And then the last fraction is first and last. So in other words, A and B together over D and B together.
Oh, okay, thank you, ma'am.
Okay, that's where it comes from. Okay, so you can just say that to yourself as you're doing it. First two over first two, second two over second two, first and last over first and last. Okay, and then remember to write your reason. Okay.
Excuse me, ma'am.
Yes, Stefanswa.
I get why that is. Why AC over DA, right? I get why we say that, but why? I get we say that, but why do we say that? Like, is there a reason or is that just why it is?
Yes, the reason that we're saying this is because this is what they want us to prove. So we need to establish this line over here before we can prove what they want us to.
Okay, ma'am.
Okay, so in other words, what is so complex about this question is the fact that they have asked us to prove a proportion. They haven't told us which triangles are similar. So there is a huge amount of work that has to go into proving this proportion before we can actually get to the final steps. Because the first thing that we need to figure out is which triangles are similar. Then once we've figured out which triangles we work in, we've actually got to prove that the triangles are similar. Once we prove the triangles are similar, we then have to write the triangles in the correct order. And once we've got our triangles in the correct order, we then need to write the corresponding sides in proportion. And then when we've done that, then we can go and produce whatever manipulation it is that they want us to do. Okay, so there are 4 big steps here in order to be able to prove what it is that they are asking us to do. Okay, so this is super, super high order. All right, it's not easy at all. Okay, DeAndre, go for it. What question did you want to ask?
So, ma'am, with regards to the triangle where you do the first and last and second and last, do we follow that order for any other thing that we will have to prove?
Absolutely, okay. DeAndre. So what I am giving you here through this example is a framework that you can use, a method that you can use that you can apply to all these sorts of problems.
Okay, thank you, ma'am.
Okay, absolutely. All right. So as long as you are doing, as long as you apply what I'm showing you here to the other things, you're going to be able to do them. Or at least you should be able to do them. Okay. All right. Are there any other questions you guys want to ask? Sorry, and then just to finish it off, it was these two proportions over here that we were working with in the last question. So it was AB squared. So in other words, we had CB over AB equals AB over DB. And then we needed to cross multiply in order to get AB squared, and then cross multiply here to get BC times BD. Okay, and we don't have to write the reason again because we've already written it here when we said corresponding sides in proportion. Okay, lovely, 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 lovely. Yes, so well, you see, this is the important. This is the thing. We've got to know the method. We've got to know how to do these things, because once we know how, then we can apply it to any of the questions that we see. All right, enough talking. Okay, it's now time for you guys to apply what it is that I have told you. So here is question number 1 and question number 2. Let me see if I can just maybe move this down just a little bit. It's just cutting off. Hang on, let me just make this a bit smaller and then try and hopefully you guys can still see that even though I've made it a little bit smaller. Okay. There we go. All right. So now I would like you guys to please try question 1. If you're a fast finisher, then you can try question 2. Okay, so you're going to try and use what it is that I showed you in the example and see what you can do here. Okay. Go for it. And please, if you're stuck, ask Yolanda and I. We're here to help you.
Romeo, I'm not sure if we did see it, but I'm gonna double check it. I'm gonna double check your question, but you can also raise your hand and ask directly.
Yeah, no, Rona, it's not okay to construct. Okay, so the only time you will ever be doing any constructions is when you are doing the proof of a theorem. So you cannot go and construct lines to make triangles, no. Sorry, we didn't, both Yolanda and I missed that, okay. Okay, so Bernadette, what you're gonna have to do is it your first day today, Bernadette?
Yes, ma'am. Yes, yes.
Okay, all right. So Bernadette, you are going to be lost because you're joining this course and this is already the 5th lesson out of 6. So the best thing for you to do, Bernadette, is now that you are signed up today, is go back and watch the previous lessons, and then you will understand where all of this is coming from. Okay.
Okay, ma'am.
All right. It's all available on the website.
So, like, will you send the link for those videos, or?
Yolanda, let me just ask you, Yolanda, can we send the link to where the videos are?
Yeah, I can quickly grab it, but you can also
Okay.
just say watobe.com and then you are there at the website.
That's too much. You will write it down.
Definitely, I'll write it down for you. I'm sending it to you in the private message.
Okay, thank you.
Yeah. Lutando, you're not alone. All right. This is the most difficult thing that we do in matric. So if you are feeling confused and this is difficult, it's meant to be confusing and difficult. All right. So remember, there's lots of other sections that you would be able to get marks on. Euclidean geometry is definitely, it is very difficult. What I'm showing you now is very, very difficult. All right, so it is hard to understand. And this is why your understanding of geometry from grade 8, grade 9, grade 10, and especially grade 11 is so important. You've got to go back to those basics and be able to see what it is that we're talking about. Okay, Fenta Tabang, you are asking, is a equal to B2. So Rona's also saying that A equal to B2. No. All right. A cannot be equal to B because we do not have parallel lines. They have not told us that AD is parallel to BC. What they've done is they've told us that ABC is a cyclic quad. This is why I'm saying our grade 11 Euclidean geometry is so important. So what do we know? There's two things that we know that we were taught in grade 11 about cyclic quads. Okay. The first one is, okay, the exterior angle of a cyclic quad is equal to the opposite interior angle. So that means, guys, that angle B2 is equal to angle D. Okay, or we could say that angle C2, being the exterior angle of the cyclic quad, was equal to A. All right, exterior angle of a cyclic quad. Quite right, Darren. Let's just do that a little bit.
Lebohan has a question. Lebohan, do you want to ask?
Go for it.
Lebohan, you have to unmute and then you can ask.
Oh, hey, ma'am.
Hi,
You already
Lebohan, how are you?
proved. I'm good, thanks. And yourself?
I'm fine, thank you.
Oh, yes, ma'am, you already answered me because I wanted to ask that if angle ABDC it's a cyclic, then
Yes.
angle C2 is equals to angle A. That is the exterior angle of a cyclic quad.
It is. It is. You are quite right. Perfect.
Oh,
Got it.
thank you, ma'am.
It's a pleasure.
Ma'am, this is so boring because like I'm relaxed seeing you guys doing a lot.
Yeah, no, it's going to be difficult, Bernadette, when you join now, Shane, because, you know, we've been through so many things before this that you've unfortunately missed out on. So the best thing is to go back and go and have a look at the videos. All right, and Yolanda will post the links for you as well, but it's very easy. You just go to watobe.com. All right, and it's all there for you.
Okay, thank you, but I'll do that later.
Yeah, no, absolutely, absolutely.
Yeah.
Just answering some questions here. Yes, Nakedi.
Can I ask, ma'am?
Yes. Go for it.
What is happening? What is happening between angle A and angle B1?
Okay, so angle A and angle C2 are equal to one another because of exterior angle of a cyclic quad. And angle B.
No.
Oh, sorry.
No, my question was because of the angle A, D, B, and C attaching the circle. I was asking that what is the difference? No, what is the relation between angle A and angle B1?
There's no relationship between angle A and B1. There's no relationship. So if you add angle A to angle C1, you'll get 180. But there's no relationship between A and B1. And there's no relationship between C1 and D either. Okay, but if you add B1 and D together, you'll get 180. And if you add A and C1 together, you'll get 180. Okay. Yes, absolutely, Sihawu. Okay, angle E is common to both triangles. Yes. Lesedi, B2 equals C1. No, Lesedi, B2 does not equal C1. B2 equals D. Okay, because of exterior angle of a triangle. Those B2 and C1 are not alternate. Okay, AE and DE are not parallel. So B2 and C1 are not equal to each other. Okay, so what's important with this question? Let's just have a look, Raphael. Yes, Raphael, that's correct, what you've just written to me. Yes, 100%.
Yes, Lebohang. Lebohang, you can talk.
Ma'am.
Hi, Lebohang.
Yes. Can I ask again?
Of course.
Yes. In angle A, B, C, and D, we said a concyclic because they lie on a circle.
Yes, correct.
So, yes. So if AB, AC, and DB also and CD are chord, right?
Yes.
So I proved then that if angle A is called to angle C and angle B is called to angle D, because are lying in the same segment. Is that correct?
No, that's not correct. So angles in the same segment is when you have, this is angles in the same segment. Let me just quickly go back to this. Okay, if you look at this diagram over here that's on the screen at the moment, AC subtends D and B at the circle. So B and D are equal to one another because of angles in the same segment. Okay, it's the bow tie. Okay,
Thank you,
remember the bow tie. So this angle over here and that angle over there. And then similarly, it would be this angle over here and this angle over here would also be one another. Okay, but that's what it is. Okay.
Okay.
All right.
Okay, thank you.
No problem. All right. Have all of you been able to establish which triangles you are working in? Because remember, this is our starting point. We need to work out which triangles we need to prove are similar. Have we been able to do that for question number 1? Do you know which triangles you're working in? Thumbs up or thumbs down? Do you know which triangles you're working in? Okay, Angel, that's fine. Okay. So what's nice is that a lot of you have established which angles are equal, but we first got to figure out which triangles we're working. Okay, so hang on. Offense, you said AED and BEC. I'm just writing that down. AED and BEC. So Offense said that. AED, EBC, fine, Masengo. How AED and BEC. Pagelo, you think so? AED, away to no. Swonka, no. Okay, Pagelo, you're only going to be working in 2 triangles. BCE and ADE. So Asanele, you're okay, Tsahofatso. All right, so those of you that have figured out which triangles you're working in, all right, that is brilliant, okay? The rest of us, so you continue going, right? The rest of us that said no, remember we are doing numerator with numerator. So AED, now we're going to look at the diagram and we're going to ask ourselves, is ADE a triangle? ADE, and the answer to that is yes. Now let's do the denominators. CEB. Okay, so now we're going to ask ourselves the question, is CEB, sorry, A, not an, a triangle? CEB, yes it is. Okay, so there you go, all right? AED and BEC is correct, okay? That's how you have to find your triangles. Okay, so a crossways worked. We didn't have to go around the outside. So the first thing that we had to write down here is which triangles we are working in. So in triangle AED, and remember here the order is not important, and triangle CEB. Okay, that's the first thing we need to establish. Now we can start setting out our reasons. No, Angel, this is similarity. Okay, similarity, not proportionality. Okay, proportionality, we need parallel lines. Okay, Nkoniza, yes, lovely. E is common, beautiful. Love it, love it, love it. Okay, so again, you've got one triangle nestled inside another. So let's just get rid of that. Let's highlight the triangles for you. There's BEC. And here, oh, different color. Is ADE, the big triangle. Okay, and that little pink triangle is nestled inside, and quite right, they share angle E. So I don't know if the rest of you saw that, but in the chat, Nkoniza said, would the reason for E be common point, common angle? That's what Nkoniza means, but yes, you are correct. You are correct. Okay, so here we could say that E is common. Okay. And then we can do the rest of what we were saying earlier. All right, about the exterior angle of a triangle. Let's just have a look at the hands. Pigelo, go for it.
Good evening to everyone. Hi, ma'am.
Hi, Pigelo.
Ma'am, I'm stuck I failed to change. So I'm done proving that it's similar, right?
Okay.
But I failed to change it into that fraction thing.
Okay. All right. Pigelo, I'm going to do that right now. I'm just going to finish the proof for the similarity, and then I'm going to show you how you would write the corresponding sides in proportion. Okay, what's important, Pigelo, is that you've got the order of the letters of the triangles correct.
Mm-hmm.
Okay, so just bear that in mind, and I'm going to come straight back to you, okay?
Okay, thank you, ma'am.
Okay, no problem. Nakedi, do you want to ask a question?
Nagedi, you must unmute yourself and then you can talk because we cannot hear. So you have to unmute. There's a on the mic. You have to press on it and then you can talk to us. There we go. Well done.
How are you?
We're good,
Hi.
Nagedi.
Hi, Nakedi.
I did try number one, so I wanted to ask if I did correctly. I said in triangle ADE and triangle BCE, right?
So,
And
sorry,
then
just name your triangles again, Nakedi.
I said triangle ADE.
Yes.
In triangle BCE.
Yes, lovely.
Okay, so I said angle A is equal to C2, which is exterior angle is equal to the opposite interior angle. And
lovely.
I said angle B is equal to angle B2, which is exterior angle is equal to the opposite interior angle.
Lovely.
And then I said angle E is equal to E, which is common.
Lovely.
And then I concluded by saying triangle ADE is congruent to triangle BCE. I said angle.
Lovely. So you said ADE. So then here you must say triangle. Which letters did you use?
Wait.
So when you said triangle ADE is similar to what was the order of the letters of the second triangle?
Oh, it's BCE.
Okay, now there you have made a little mistake. Okay, remember all these angles over here, all right? So in other words, the ones on the left-hand side belong to the yellow triangle. So we've got E, we've got A, we've got D, all
Yes.
right? The ones on the right belong to, sorry, what's actually the little pink triangle, okay? So here we've got E, then we've got C, then we've got B like this. All right, so if A came first over here, C has to come first over here. Okay, so the first letter I've got to write here has to be C. Then if D came first over here, B has to be second over there. And then E would have to be at the end. Okay, because the order of the letters is important. And then you can write angle, angle, angle. Nakedi, that's very good. Well done.
So after that, I said since triangle AB is congruent to triangle CBE, then I conclude by saying AD over BC is equals to AE over BE is equals to DE is equals to over CE. Then are therefore AD over BC is equals to AE over CE.
Okay. All right. No, you're absolutely on the right track. As long as you get the order of your letters correct, okay, you will be absolutely fine for the next bit, 100%. Okay, so now, who was it that was asking? Wasn't Lebogang? Figuelo. Okay, you said that you got to this point and now you were stuck. All right, so now in order to conclude this off, we're going to do exactly what Nakedi was saying to us. All right, so we're going to say the first two letters over the first two letters, and the second two letters over the second two letters, and first and last over first and last. Okay, reason, because the corresponding sides are in proportion. And now let's go and have a look at what it is they gave us. All right, so let me just get rid of that because we were using that to establish triangles. Okay, so we want AE, there's AE. We want CE, there's CE. We want AD, there's AD. We want BC, there's BC over there. Okay, so now that we have got all of this correct, we can now conclude what they gave us. All right, so that means that AD over CB equals AE over CE, and they wanted AE. Okay, well, that's exactly it. All right, we've done it. Okay, so they just wanted this fraction first, and that one second. Okay, are there any questions? Okay, so Sihawu, you said you used AED. Let's just move this up here. AED, and you went AED. Yes, that would be wrong. Okay, Sihawu, that would be wrong. Okay, so if you go AED, Sihawu, you have to go CEB. Okay, the order has to be the same. Okay, so Vidard, the way that it would be marked is that first of all, there would have to be marks for you establishing which triangles you're working in. All right, then there would be marks for proving that angles were equal. So certainly on something like that and something like that. Okay, then there would also be statement reason marks for this, and probably for you getting to this line over here. Okay, so that's how they would mark it. Okay. Any other questions you guys want to ask? Nkoniza, 1, 2, 3, 5 marks. Maybe they would make it out of 4. They could push it down to 4, but yeah, probably out of 5 marks. Okay, so yeah, difficult, very, very difficult work this. Okay, so don't feel discouraged, Matrix. This is going to be the hardest thing you do this year. The work in blue pen is for which question? It's still part of the same question, still part of question number 1. Okay, so it's us or me writing the corresponding sides in proportion after I've got that statement where I'm concluding the triangle ADE and triangle CBE are similar to one another. Okay, so it's all part of the same question.
Matsiko, is that hand up to ask a question? And can I also put the poll, Teacher Lee, or not?
Yes, no, you're welcome to. Before you do that, if you want to try question 2, you're very welcome to take a screenshot and do that for homework. Okay.
No worries. Anyone who's having a bad network because it kicks you out and in, we are aware of that. And because Teacher Lee and I are very nice, we have recorded everything for you. So you can find it on the website, okay? By tomorrow, this lesson will be posted. So if you did miss some bits and pieces, please go through it and try and understand the questions that we did, the examples that we did. It will really help you. And this is very difficult. I find it difficult myself. So y'all are not alone. And well done, guys.
Yeah, well done, everybody.